In any triangle ABC, if the angle bisector of the angle A, which means a line which is cutting the angle into two equal halves, and the perpendicular bisector of BC, that means a perpendicular line which is also cutting BC into two equal halves, intersect, prove that they intersect on the circumcircle of the triangle. So if they intersect at D, we have to show that D is on the circumcircle of the triangle ABC. Welcome to Mathotropism. So, understanding what is given and identifying the concept. Given is a triangle ABC. We are going to draw the circumcircle of triangle ABC, which means a circle which is touching all the vertices A, B and C. Now let MD be the perpendicular bisector of BC touching the circle at D. So which means what? Perpendicular bisector means both the angles must be equal where it is cutting. That is, angle BMD should be equal to CMD, which is equal to 90 degree. And BM should be equal to CM. That means the line is cutting BC into two equal halves. Now we need to join AD. What we need to prove is AD is also the angle bisector of angle A. So, which means what? Angle BAD should be equal to angle CAD. Now, how to prove this? We can see that angle BAD is lying on the segment BD and angle CAD is lying on the segment CD. Now, we need to prove that both the segments or both the chords are equal. BD is equal to DC to prove that these two angles are equal. Therefore, these are two sides of the triangles BMD and CMD. So, if we can prove by the congruency that these two triangles are congruent, we can show that the sides BD and CD are going to be equal. So, we will take the triangle BDM and triangle CDM. So from step 1, angle BMD is equal to angle CMD, which is 90 degree we have taken from the given point, and also BM is equal to CM. We can show that DM is the common side. So by SAS congruence, we have the triangle BMD is congruent to triangle CMD. Since both are congruent, it means both the sides CM and BD and CD both are equal. Now since both are equal, we know that angles subtended by equal chords are equal. So that means the angle subtended by BD is angle BAD and angle subtended by CD is angle CAD. So both these angles are also going to be equal. If both are equal, it means that AD is cutting the angle A into two equal halves. That means it is bisecting angle A. Hence, both the lines, that is the angle bisector and the perpendicular bisector of angle of BC, both are intersecting on the circumcircle of the triangle ABC at D. So this is how we are going to prove. Forming equations and solving the sum, we have given is the perpendicular bisector MD of side BC of a triangle ABC is intersecting the circumcircle at D. So as a result, since it's the perpendicular bisector, BM will be equal to MC and angle BMD will be equal to angle CMD, which is both 90 degree. Let us keep it as equation 1. We need to join AD and we need to prove that AD is the bisector of angle A, which means angle BAD should be equal to angle CAD. So the solution is, we will start by taking the triangles BMD and CMD. We have from 1 that BM is equal to MC, which is given, and also angle BMD is equal to angle CMD, both of which are 90 degree. Now, we also know that DM is the common side, so we will write MD is equal to MD. Therefore, by SAS congruency, we have triangle BMD is congruent to triangle CMD. Now, which means that the sides BD will be equal to CD, which implies angle BAD will be equal to angle CAD, because BD is subtending the angle BAD and DC is subtending the angle CAD, and we know that angles subtended by equal chords are equal. So as a result, my AD is bisecting angle A, which means that it is the angle bisector. Therefore, the angle bisector of angle AD and the perpendicular bisector of side BC of a triangle ABC intersects on the circumcircle of the triangle ABC at D. Thus, we have proven. Thank you.